Hi guys! Today we will talk about encapsulation principle in object-oriented programming. When talking about encapsulation, often says about private class members, and it is correct, but it covers just part of the principle. Encapsulation is a concept of building data-related variables and properties with behavioral methods in the same class or code unit. If we are talking about privacy, we can give another definition. Encapsulation is an approach for restricting direct access to some of the data structure elements, like fields, properties, or methods. Let's look in example. We have real-life component, a car. Using abstraction principle, we can define context of data that would be needed in our application. In this case, we will need car properties like model name, current speed, max speed, and Boolean engine property that will be responsible for state is car turned on or off. Encapsulation principle means that we should add to the same class behavioral methods like drive, stop, set speed. Those may be used in our application. And also to provide restricted access to changes in the class instance state. We don't want client of our class to be able to turn off car and then still was able to set its speed to 100 miles per hour. In more complex applications, you may need more properties that describes the other car subsystems like lights or helm. In that case, you will have to make few abstractions for that subsystems, which will encapsulate its state and behavior, and then you'll be able to compose car class with all that functionality. Anyway, let's try to develop described example. We will create our class named car, and we'll start from constructor. We will pass arguments like model, then speed limit, and we'll create those properties. Model equal model, is that speed limit. It's good. Also we will need some property like speed that will show the current speed. It will be 0 by default, and one more property, this.engine, which will describe the state of our engine. Is it turned on or off? By default it will be turned off, so it's false. Okay, then let's try to create some method that will be able to change the speed. So something like set speed, argument speed, and also I would like to make it not immediate, so a car will reach this speed in some time. So I will use set interval to increase the speed step by step. For that also I will use a promise. We will have resolve, callback, and reject here. Cool. So I will check some basic state of car before set the speed. First of all, I will check engine if it's turned false. If it's false, if it's not turned on, I will reject this with message please turn on engine, or engine turn on. Okay. Else, if I also would like to check if this speed limit is less than requested speed. If it's less than requested speed, I will also reject it and will message user speed limit or speed should be less than this dot speed limit. Cool. And else I will try to increase it, but as I said, I would like to use interval. Set interval, and as argument it will have a callback function, and here I would like check if speed is bigger than, if requested speed is bigger than current speed, I will increment the speed, current speed. Okay. Else if speed, requested speed is less than current, I will decrement it, decrement current speed. Cool. And otherwise it means that requested speed is equal to current, so I will resolve this promise. Just pass speed argument. That's good, that should work, but also I would like to create some drive method that will be able to turn on engine, true, and will be able to set speed. I will use also some argument here, speed, and I would like to make this asynchronous method because I would like to message that driving, the car is driving with speed this dot speed, but before I message it I should wait for set speed methods. Okay, cool. So drive is working, and also I would like to make something like stop. It won't receive any arguments, it will just await when this dot speed, set speed will be 0, then it will turn off the engine, false. Okay, and console.log that car stopped. Okay, looks like that's everything that I plan to do in this class, and I would like to create some test function for this test drive. So I would like to create an instance of a car. It will be new car, car model will be Tesla, okay, and speed limit 100 miles, or any speed units you like. So then I would like to start car, I would like to drive, okay, and then car, let's stop. Okay, let me check if everything's okay. I missed here, I have to clear interval, okay, and also it will be good to console log the change of speed. Here there's that speed to see how it's going up or down. Okay, what else? Here I will pass some argument like 30 miles, and it will be good to make this also asynchronous method, because I'd like to leave more comments in console.log driving, and then await console.log stopped. Okay, good. So now we can try to test it. Test drive. I will try to test it in Node. So first of all, I'll run it here. Theory.car. Okay. Yep. So looks like it works as expected. Oh no. Okay. Let's try one more time because I made some mistake here. Yeah, car stopped, and driving with speed setter. So looks like it's working. I don't know, we can try to test some other cases. For example, when we have increased more than speed limit. Yeah, and we have here some promise that is rejection that is not handled. Let's try to handle it somehow. Let's try. What if we will do something like here, catch an error. What we will have now, one more time the same mistake with console. Okay, speed should be less than 100. So that's all, that's working. So here we have some example of encapsulation. So we have encapsulated these three methods and these four properties, for data properties, together in one class. So we have encapsulated all the logic that is needed for car instance. Okay, that's good. That's one part of encapsulation. But about the second part, about privacy, about private method, why do we need them? So in this case, if our client of this code will try to do something like change some property state, for example, for when we are driving, then he can change some engine to false, then he can change the speed, so the engine will be turned off, but speed will be changed to 20 miles, for example. So in this case it will behave not as expected, so he can easily break something. So we would like to make this code safe to use, and we would like to prevent such situations when some client of this code will use it incorrect. So that's why we would like to make some private things. Okay, but before it, I'd like to check it in browser if it works. Looks good. So in browser it is the same, it working the same in Chrome. Cool, let's go back to Visual Studio. We'll try to think about some of the options that we have for privacy. So the first option that we will consider is just convention, which is the most popular, I guess, and we can use just prefix for our private fields, something like underscore. This is the most popular one, but you can use the other prefix, or you can add underscore to the end of the field, and it will show for the other developers that it is private field. Let's create new file for that. carconf.js. Okay, we'll pass everything, and we will include this file to index.html. Cool. So here we will try to first of all, let's look one more time in browser how our object looks. We'll console log it. Log car. Okay. Okay, here we have car, here we have access to all the properties, and for example, let's try to make engine private property. So for that, we will go back to Visual Studio, and we'll just add underscore, which will mean that it is private. And it will be good to add setter for this property. If we want to change it, we can have a setter. For example, it will call just engine, that can be safe to used by clients of our code. In this case, we will have value that is passed, and this dot underscore engine will be equal to value. Okay. In setter, we can check if the state of our car gives ability to turn off it. For example, if speed is equal 0, then we can change the state to turn off, or I think also to turn on, because we won't have such case that car is driving by 10 miles and it is turned off. Okay, so it can work, and also we can add getter, of course, and getter just will return this dot engine, this dot underscore engine. Cool. Let's see what we have now in browser. Yeah, so we have underscore this field, and users of that field will think that they are not able to do it, so they will use public getter and setter to work with engine. So let's consider the next option. It will be defining all the private properties in the constructor method, and inside of that we will have to also define all the function, all the methods. So let's try to do it. Car constructor.js. So we will have to define all these private properties inside of the constructor, because we will, in that case, we will be able to access it here. So we'll have to move everything, I guess, here. So let's add those functionality. I think this version we don't need getter and setter, and we will have to define this as a function and set speed and async function drive and async function stop. Okay, good. And now we have to change the usage of the this.engine on just underscore engine. Good. Correct. And what else? We have to prepend all these function to object that we're instantiating. For example, set speed equals set speed, and this dot drive equals drive, and this dot stop equals stop. So let's test it. Constructor. Okay, let's open our browser. So looks like it works. And what we have inside of our object, so we don't have here access to an engine property, so it's private and you can do nothing to access it. But in this case you see that set speed and stop and drive are methods that are created in each execution of constructor method, so they are prepended to each object. They are not in prototype. This is bad, I guess, and this is one of the reasons why I don't like to use this approach. And the other thing is that you have to define everything inside of the constructor. So this way of creating private properties is the same as creating constructor method in ECMAScript 5. So the approach is the same. Okay, let's go forward and let's look. Let's go back to our Visual Studio and let's try to do one more approach. It will be approach using WeakMap. So car underscore WeakMap.js. Okay, cool, and let's use it here. Car_underscore WeakMap. I will copy all my code from here, from the convention car file, and we'll pass it here. Okay, so in this case we would like to save private properties in WeakMap. What does it mean? It means that we would like to create immediately invoked function inside of which we will save those weak maps that are reference to some private function. So we will have some variable, for example car, which will be reference to our car class, but we will create this class inside of the immediately invoked function that will give us ability to have some variables inside of the scope. Okay, looks good. So here we can create some constant variables like, for example, engine, and it will be new WeakMap. Good. So inside of this WeakMap we can save some properties by key, and key can be object. So each instance of car can be a key for the WeakMap. So let's try to do it somehow. So engine key this equals false, and it's good to have a getter and setter here, and we can use it. One here and one here. Okay, this should work. So this setter should cover this functionality, so everything should work. Let's go back in browser and we will check it. Okay, I have so I've saved it in wrong file. Sorry for that. I will move it to WeakMap now. We'll save it, remove this unneeded file, and go back to Chrome. Yeah, and we see that it is working, and we still not able to see the private engine property underscore engine. So just we have access to the public getter and setter here. That's good, that's what we want. So, and the last option that we can consider is just using a symbol, ECMAScript 6 feature. So let's create one more file. It will be car symbol.js. We can reuse the code from WeakMap example. Let's try. So here we can use a symbol inside of the closure, create some unique property, unique key. So we can use it in the same way as we are appending properties to our instance of a class inside of the constructor, and we can just reuse it inside of the getter and setter here. So okay, nothing specific here, just using the symbol instead of a property key name. That's all. So let's save it and let's try to run it in browser. Car.symbol, car symbol. Okay, let's look. So it works, and what we have here, we have just a symbol instead of the engine. So it's still accessible for user because there is such a method like get own property symbols that is accessible on object, so users still can access this property value. So that's all that I'd like to discuss in this video. We can summarize that encapsulation is a data and methods together in one class, and also it covers a restricting direct access to some of the data structure elements. So in this video we have created class and investigated issues when user is able to access to all its properties. We have looked through few workarounds how to restrict access to the user. So I hope it can be helpful for you in future to know such approaches, to understand more deeply encapsulation, and probably you can use some of these approaches in different situations. So thanks for watching. If it was useful for you, you can like it. I will be appreciate if you will leave some comments, suggestions or corrections, and it will be motivating for me to create few more videos about some programming principles and its implementations in JavaScript. So thanks, see you, bye!